Hi, I'm Joey Henderson here with iConnect Training, and today I want to show you our TU-9230 Refrigeration Training Unit. If you look at this from a big picture standpoint, what we have a split refrigeration unit. Here's our indoor section, here's our outdoor section, and the really neat thing about this is actually a medium temp and a low temp refrigeration unit. You can control what box temperature you want with this system. If we start down here at the lower half of the outdoor unit, let's take a look at this. And when you open this up, this is a live training unit. Everything's working. So we've got the electrical circuits here. We've got our wiring diagram over here to show our students. You can even, I've had them cover this up and make them draw it out by you right there with their own self, and then they can check it. So down here we have our contactor, we have a relay, a time delay relay, we have a low pressure switch, and we have our capacitor down here. We have a toggle switch here, and you can run this as a normal unit, go through the basic refrigeration cycle and show them how, no matter whether it's a medium temp or a low temp, refrigeration cycle is still the same. From there we go into the electrical side of it, and we've got fault switches built into here. So these fault switches simulate several different things that we can do in real time. One of them is that we can actually flip one switch and simulate a compressor that is no longer pumping. So we'll actually open up the high side to the low side, and all of a sudden there'll be no pumping action. And this is a great opportunity to have the students explain why that's going on. And then you can, once they determine it, you can flip the switch back on, and it's like they put a new compressor in. Another fault switch will kill the low voltage to the contactor, and this will give you a chance to simulate a loss of low voltage from the control board, from the transformer. You can even use it to simulate a failed contactor with the students, and going in here, they'll have to go and actually use their meters to find out what the problem is. Another switch will actually kill the outdoor condenser fan. And with that, of course, what I like to do as an instructor, again, is have them explain to me what would happen if we lost the outdoor fan. Once they give me their ideas, then we actually kill it. Another thing you can use is have them troubleshoot electrically what killed the fan and why it's not working. So with these scenarios, you can actually do refrigerant and mechanical and electrical training all at the same time. Another fault we have in there is that we're going to take out the electronic expansion valve, and then we can also kill the communication between the inside and the outdoor unit. Altogether, we're going to have 6 faults built in here, and there really is no limit to what you can add to that. The other fault we have on there is our low pressure switch here. We'll open the circuit for that. And again, that's a great troubleshooting for letting them find out why the unit no longer works. We come around here on the middle of it. Up top, we have our high voltage controls. And here we have our regular disconnect. We have our fuses in here, and as you know, we can always sneak in some bad fuses and let them troubleshoot that, learn how to ohm out fuses and check fuses. How many times we've been stuck with that. Up here on this box is for you. We have over here on the side toggle switches for your high voltage. So we got a 208 and a 240. All you got to do is flip the switch to whatever voltage you're using in your lab. Now we have the voltage switches down here. We have it over here up top, and then we have the high voltage switch down here. So whatever the voltage is in your lab, then you'll want to flip that switch to either 208 or 240. We have a condensate pump here for our drainage. What I really like about this is you can build onto this. We have the condensate running like we normally would. We do have tubing that comes with it, but we also have accessories over here on this condensate pump for alarms. You can have the students wire in those circuits themselves, which is really a great training aspect of it. Now, once we move from the down here, we're going to move up to the indoor section. On the indoor section, you can see we've got a plexiglass box here, so we can actually see what's going on inside the system. We have an airflow adjustment wheel here, so we can adjust the airflow coming out all the way to 100% closed. We have another one just like this on the back side. So you can play with airflow on either side of the coil. We have an access door here, so they can actually get in and then get into the controls for troubleshooting. And you can also, of course, teach them how to take controls. Up top here are our other two toggle switches for doing simulations. This is the ones that will actually take out the electronic expansion valve. It'll also take out the communication between the indoor and the outdoor unit. If you look over here underneath the unit, we have a heater. We can actually adjust the load coming in on the back side of that coil with a thermostat down here. This thermostat controls the heater itself. We have a toggle switch over here. Then you can adjust how much load you actually want to put on this coil. So you can simulate a hot pull down if you want to. So that gives you the ability to choose the environment this indoor coil is going to be working on. And again, at the same time, you can choose whether it's going to be medium temp or low temp. We can get down the negatives with this box and go all the way up to 70 degrees if we want. On the side over here, we have our heaters. We have an overload, temperature overload switch. We have drain pan heaters. And we've also got our thermal strip up here. And again, we have access to all of this through the actual casing itself. So the students have full access to it, and then you can actually close it up and run it. On this side over here, we have a electronic expansion valve, we have a low pressure transducer, and we have permanent gauges that will actually give you the low pressure and the high pressure all the time. Down here we have our service valves, so the students can actually hook the gauges to it. They can check the subcooling, they can check the superheat. They can get all that information also from the control up here. And inside here we have our basic refrigeration components. So together we have a complete split low temp and medium temp system all in one.